That's pretty great.
Wait, is that his leg?
Hi friends! Welcome back to day 3 of our Out of This World Science. I know we have a few new families who have joined us, which is awesome. I want to say welcome to you. I'm so excited you're coming for science with us. If you want a shout out, don't forget you're going to type your name into it. So for our new families, we give shout outs to all of our friends who are out there, and it's like the best part of the day. Make sure you subscribe to our YouTube channel, get notifications, follow us on Facebook and Instagram so you can know all of the cool stuff that is going on all of the time. And for our new families, don't forget that it's like come when you want to come, and that you don't have to be here all 5 days. They don't always build.
Wait a second.
Pausing because I'm getting that maybe we're having technical difficulties.
What about... Try again. Can they hear you?
Can you hear me? Uh-oh.
Trying.
We're having difficulties. Apparently you guys can't hear me.
Alright, I think they can hear you.
Can you hear me? Maybe?
Right.
Yes?
Oh, okay.
Awesome. Alright, we'll start from the top. I want to say welcome to our new families. Sorry for our slight technical difficulties earlier. One of our favorite things we do every day is shout out. So if you want to shout out, make sure you type your name in the comments box and we'll get to that after we go over supplies. And if you're a new family, make sure you subscribe to our YouTube channel. Check us out on Facebook and Instagram so that you can see all of the awesome things we're doing. And just a quick reminder that it's like, come when it works for you. So you don't have to come every single day. You can come 1 day a week. You can come 5 days a week. You can do it all. You can do a little. We're here to support you guys during all of these school closures. And on Monday, we blasted off to various places with Rosie and Watsy, who are our fun little fictional characters. And then yesterday, we designed awesome landing spots for them. And it was amazing to see what everybody did. And I just want to call a couple of people out. Everybody did amazing. But a couple things I noticed was like Lila had this problem with her rover and she like ripped it apart and used part of her idea and then did something completely different with the other part and it made it work. And it was so cool seeing engineers try something and fail and then get back up and be like, well, this part kind of worked, but maybe a different part. So we did that yesterday, which was fun. And today we're gonna learn about how to image, because it's kind of curious that we can see these pictures from Pluto or Mars or all the way deep in the galaxy from Hubble. And you might be wondering, how do we do that? So today we are gonna do that. And what you need for today is either our little lab book that we have. It was attached to your patron email that you got just a little bit ago. And it's just got like some of the fun stuff that we're gonna do. If you don't have our fun little lab printout, what you could use instead for today is a piece of graph paper. So if you have graph paper, that will work if you don't have our little printout. What you won't have if you have our printout is some of the fun little coloring activities that we have where you can learn about resolution and whatnot. And then you need a pencil. That's it. We're gonna have a fun short little lesson here in YouTube today, and then our Zoom class, we're actually gonna transmit images to each other after we learn how it's all done. It's gonna be super fun. I'm so excited. So let's get to who's here with us.
Who is here?
Who is here today?
So, let's see. First up, it's no surprise.
Oh my gosh, George.
These guys are on top of their game.
3 for 3.
All week
Holy
long.
moly. Who is going to bring down the record?
I don't know.
I don't know.
I don't know.
Might be hard. I feel like the stakes are getting higher for them. Who knows when they're getting on?
Will they be able to keep it, make it a 5-day streak?
Mm-hmm.
Second up, we have our friend Rachel.
Hi, Rachel! I'm so excited for my story.
You know what?
Rachel
I just
telling me
saw
some great stories.
an email that we might have a story
Yes!
in our email box.
Oh, I'm so excited, Rachel. Rachel has amazing creative stories, and she's been thinking up a story, and she merged her 2 stories together. So we're gonna have walking sharks with human legs, not alligator legs, and unicorns on Unicornia. So it's going to be a good one. I'm really excited for that. Oh, I'm so excited that got emailed.
And if other people want to send us stories or pictures or whatever you're drawing to go along with our lessons,
seeing all of that stuff.
we want it. Pictures.
Yes,
Photos.
love pictures.
Naomi. Hey, Naomi.
Hi, Naomi. Oh, I hope my stuff got to Naomi. Hopefully she's got her little lab printout. And if not, she probably has graph paper.
We have Isabella's buddy May is here.
Hi, May! Oh, yay! I haven't seen May for a little bit. That'll be fun.
And then Les Amis Françaises.
Ooh,
Barbara and
bonjour,
Leonard.
Barbara and Leonard.
And we have Erica's former professor, Mr. Scotchpool.
Hi. How's it going? Professor Scotchpool, he was a fun one. I got to learn about teaching from him. He's my teacher mentor from a long lifetime ago. It feels like that. Maybe it's not actually that long ago. It feels like forever. Hello.
We also have Connor and Grayson here.
Yay! Hi, Connor and Grayson. They had some really cool projects yesterday. They had some great parachutes going on. It worked really well.
The Hertz with their amazing projects are here.
Hello, Carrie and Taylor and Jacob. Did I just say Carrie?
Yes.
Yeah.
No, it's Megan.
Taylor, Megan,
and Jacob. Yes. Why did I say Carrie?
I don't know.
I'm so sorry, guys. I was just so excited to say hi to you, and I was imagining you in my head. I don't know what happened.
They had such cool rovers.
They did.
Yeah.
There was some, oh my gosh, Zoom yesterday was so much fun. Just seeing everybody's projects and everybody testing everything, that was really amazing.
I guess it's gonna be alright.
We have Ruby and Leif here.
Oh, hi Ruby and Leif! Yay! I missed them in Zoom. I know they were here earlier this week, but I didn't get to see their projects.
And Jackson is joining us again.
Hi Jackson! Oh, this is gonna be such a fun one today. We're gonna have a good time.
Callie, she had some serious awesomeness.
Oh my gosh, Callie was on her countertop yesterday, dropping it. And her astronauts survived from a countertop fall.
High countertop fall.
Standing all the way up. It was impressive. It was pretty exciting.
Raiden is saying hi.
Yay, Raiden's back! Hello, Raiden!
And
I feel like Raiden was here yesterday, but not in Zoom.
What?
I know, because I didn't see Raiden's project yesterday.
Ridiculous. We have the good kids who are hanging out with us.
Yay! Hello, good kids!
And apparently Raiden is eating an Oreo. I hope he brought enough to share.
That sounds delicious. I would like to reach through the camera and grab the Oreos and bring them back. Like Charlie and the Chocolate Factory.
Exactly.
Oreos are like those little chocolate cookies with cream filling. You can see how often my children have Oreos.
Yeah, right. And then Abel's here.
Oh, hi Abel! Oh, I'm so excited that you're here joining us today. Oh, yeah. Maybe your little brother's here today too. That's a big one.
And let's see, is there anybody else? We have Kaya's here.
Yay! Hi Kaya!
And then
Kaya always hangs out to watch Tiny Dancer and Zoom.
Is anybody else having trouble hearing us? Because Callie asked if we could talk louder. I'm not sure.
Oh. Maybe I can try talking louder. Alright, is that what we have? This is louder.
That's what we have.
Awesome. Alright, so today we are going to learn how we get images from space into our homes. And this is really, really important because to ask somebody to spend billions and billions of dollars to get somewhere and then you don't have any idea of what it looks like humans are enamored with space. We want to know all about it. We want to know, what does Pluto look like? What does Jupiter look like? What does that other galaxy over there look like? What does this star look like? And we can't know what anything looks like unless we take pictures of it. And normally if I take a picture of something, I could snap a photo. I guess really now a long, long time ago. I could snap a photo and it would be on film. And I would take the film and I would go process it and I would come back with a photo of it. But we can't take a photo on Mars and then have a printer on Mars and have it print out and then put it in a little envelope and shoot it back to Earth. It wouldn't work. Even if we got it to manage to come shoot back to Earth, it would burn up in that atmosphere that we learned about yesterday. So it wouldn't make it. So how in the world do we get images from outer space? How does that happen? And it's really cool. It actually uses a thing called binary, which is how computers talk to each other. And we can send binary code through space. So it's sort of we can do it with beeps, like a Morse code, like a beep, beep kind of a thing. And then on Earth, we can take those signals that we get from the Mars, whatever it is on Mars that's taking our picture, we can take those signals and we can change them into numbers. Today, we're only using 2 numbers, which is what binary comes from. Bi stands for 2. Just 0 and 1. And you can actually make up an entire, you can write letters with just zeros and ones. You could write any number you want with just zeros and ones. It's crazy, I know. It's different than what we think of because we work in what's called base 10, where we always have 10 digits, and we can write anything we want with 10 digits. But we could write the same things with just 2 digits, 0 and 1, which is really cool. And that can captivate sort of all of our imaginations about what space is like, and then we want to go out there. Now, our first image from Mars came in 1965 from a probe that did a flyby. And this probe sent all of its little zeros and ones back, and they had a little computer, and it printed on ticker tape. And ticker tape is like just really thin paper, and it printed all these numbers. And everybody was so excited because, oh my gosh, these numbers were gonna be the first image that we've ever had of Mars. It was gonna be amazing. And because it was our first, some scientists were like, how do we know that these numbers are right? How do we know that the program that we wrote is working? So what they did, in 1965, they took all their little pieces and strips of paper and they put it and they stapled it on a bulletin board. And they had all these different numbers that they stapled to their bulletin board. And then they went out to an art supply store and they bought a bunch of colors. They actually bought these oil pastels. They bought the art store out of the colors they wanted. And they just sat there and they colored by number, which is really cool. They colored by number and they made literally the first image that we have ever seen of Mars, and they were able to put it on television. So that made everybody in the public be like, what, that's what Mars looks like? Oh, so pretty. And then everybody was saying, you guys can go back there. You guys, let's definitely fund a rover to go land on that really cool planet we saw. And they have all the money they need. Really cool. In fact, if you have our printout on the very back page, we have the first image of Mars. We have it. So I actually contacted the scientists at the Jet Propulsion Laboratory at JPL a couple years ago, and I begged them for the data. Let me tell you, it was so much data. So much, like thousands and thousands and tens of thousands of pieces of data. But what I did is I actually averaged it out and I made it small for you guys. So what you can do if you want to at home is you can actually color this from Mars just like the numbers, and you will have original JPL data, which is super cool. And you might be looking at this and being like, Dr. Erica, there is more than zeros and ones. And that's because I actually translated some of the zeros and ones into the larger numbers that they represented. So today we're actually just going to use zeros and ones. And if I have just 2 numbers, that means I have also just 2 colors. So I only have black or white. So white is sort of a null number, so that white would be if there's nothing there. And then 1 would be if I'm colored in. And if you have our little other sheet, we also have some fun little things you can draw with zeros and ones. And this part actually looks at resolution. Isabella and Georgia have been working on them. And it's sort of a fun, quick little project. If it's a 1, you're going to color it in. And you're going to see a little picture. And I'm not sure. Let's see. Did Georgia finish yours? Can I show them yours, Georgia? Mm-hmm. So this is what Georgia has so far. We've got, I'm going to color on these ones too. So we go from sort of a blob here, I'm not so sure what that is, to something more here. And that's because my boxes actually got smaller. So my resolution is better. I went from sort of a fuzzy image to a better image. And if I were transmitting this image, if I was going to get it, I'd say like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1. Oop, these guys are ones. And I would keep going and read off of these numbers. In fact, in Zoom today, after we create our own images, you guys are going to have a chance. We'll do like a random number generator. For one of you guys can read off your zeros and ones, and the rest of us can shade in the boxes, and hopefully we'll get your same image. So, totally a blob here, kind of a blob here, but maybe a little bit more. I mean, I can see there's more of like a window or something empty here, maybe some legs or something going on. And then we also have it where it goes to very high resolution. So these pixels, these little boxes are actually very, very small here. And that helps me see different things better. It helps me see the smaller objects or the outlines. And I think Isabella is still working on that part. So we don't actually know what this guy is going to look like. But that's something that you guys will get to be able to do too. And I do want to show you how to make your own image and how to transmit your own image. That's fine. Oh, hang on, Georgia. I think I gave you a couple pieces of my paper. Here we go.
You need the Curious George book?
Oh, a Curious George book would be great. So here is one of the sheets. Now, if you don't have the printout, what you could use is just a piece of graph paper. It would be the same type of a thing. And in your head, and you guys can do this while we're talking, you're going to want to make a picture. So you can make whatever you want, but you'll find it's going to be tricky because you can't make nice curves the way you might want to curve. Because the box has to be either a 0 or a 1. So you only get one of those two states. So it's either filled in or it's empty. So let's say I want to draw, I don't know, maybe I'll try to draw a unicorn horn or a unicorn head. So maybe I'll have an ear that comes here and it's going to come down, and maybe I'll have its face that comes out like this, and it's going to have a horn. Maybe its horn will come out at an angle. So what I could do, and you can do this in pencil if you want, but I'm going to do it in Sharpie, is you can color in the boxes. Oop, my Sharpie is running out already. You can color in these boxes that you sort of sketched in, and each box you have to color in all the way. So you don't get to do like a half of a box. So your picture won't quite look exactly how you were hoping. I think I'm going to do this with actually blue, just because I have this great thick blue Sharpie. So you'll color over it. Oh, that's going to be so much easier. Like this. So this is my outline. And I've got my little unicorn. And if I want to try to make something that's like maybe not quite so blocky, I could try to sort of come down like one square here. And then maybe a couple of squares here.
Rachel wants to know if that's from Unicornia, if that unicorn is from Unicornia.
It is a picture from Unicornia. For sure. And then I could come down here like this. And these guys are all going to be colored in. And then it'll come up like this. And I've got to color in all of these so that my unicorn is colored in. Although maybe I leave this top one open because their ears are a different color. They're lighter. All right, so here is my unicorn. Ooh, I should leave an eye spot actually. So we'll put an eye spot in here. Like this. And we're gonna color it all in just like this. And of course, if it's a unicorn, after I color this all the way in, I'm going to have to add what, Georgia? Right now it's just a horse.
You're gonna add a tiny unicorn.
Tiny unicorn horn!
Where?
It's gonna come up like this. So it's gonna go in a diagonal. So it's gonna look like this. This is my unicorn horn. I could make my unicorn horn look better if I had better resolution, if my boxes were smaller. But this is what I have. Just like once we send a camera into space, we're sort of stuck at that resolution of whatever camera we were able to send. So now if I wanted to transmit this data, I have to know how to read it off. And the way that you read it off is you always start in the top left corner and you just read off your numbers. So here I would read off 0 because it's blank, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1. And then I could also say all zeros for the rest of the way. Or when we're in Zoom, sorry Georgia, one thing we could also do is I could count how many zeros. And I could say this is 1, 2, 3, 4, 5. So I could say 5 zeros. And then in Zoom I'd be like, all right, 1, 2, 3, 4, 5. And then 1, 1. And 1, 2, 3, 4, 5, 6, 7 zeros. And I go 1, 2, 3, 4, 5, 6, 7 zeros. And I can say 1, 0, 1, 0, 0. And sometimes it's nice, like sometimes on our things that come back from space, we actually say new line. And we tell our computer, oh, now we're onto a new line. And we will go through this and we will map out our pictures. So I would read it, and it takes a little bit of time, but it's a lot easier if we actually count and say how many zeros or ones there will be. And what will be really fun is in Zoom, you guys can all guess a number, and we'll use a random number generator, and we'll pick our person who gets to transmit their image. And we'll all try to follow along and plug in what their image looks like, and then we can show it. Because sometimes we have what we call transmission errors, when it was supposed to be a 1, but we actually read it as a 0, or it was supposed to be a 0 and we actually read it as a 1. So maybe you did a picture of a flower and maybe the flower is like a little bit off, and that's okay, because that would just mean that, oh, we had a slight transmission error. But it'll be really fun to see how many of us come up with the same thing as we transmit these. And you can make really fun things. You can't make them super complex because you can imagine the size of the squares are inhibiting that. But if you use something with really small squares like this, you could actually make a pretty great image, except for it would take a long time to transmit your data. Of course, when the Mariner 4 mission went by Mars and we got our data back, we had thousands upon tens of thousands of pieces of data that we had to go through. So actually getting a picture is a ton of data. It's not like a small amount, but that can be kind of hard. It's sort of fun to go with what we can do here. And what's really nice is we have the snap your shot spot right here, so that this part you can use to draw what you want to do, and you can use it to map out your 0s and 1s. And then today in Zoom, you can use the bottom one to write in somebody else's 0s and 1s. And then as we write it, we can color it and we can share what we think we're gonna get, which is really fun. And that is sort of how we transmit in space. It's all with 0s and 1s, and that is actually how computers talk, all with 0s and 1s. And that's because computers talk using magnets, or up until now they have. Sometimes we have different ways to talk at this point, but they've mostly always talked with magnets. If you've ever played with a magnet, you know a magnet has a north and a south, so it's sort of like a top and a bottom. And so if it's one way, it could be a 0, and if it's the other way, it's a 1. And your computer writes all these tiny little magnets, and then it can pull up whatever you did. If that's an image or a Word document or my video of me talking to you or just a song of a music, all of that stuff gets encoded into your computer into lots of tiny little magnets of 0s and 1s that go up or down, up or down, up or down. And then we use a little magnet to read it, which is really cool. And then all of our letters are actually 8 0s and 1s combined, which is super amazing. So we have to like make chunks of things. In fact, if you have this printout, WotC does say something in binary here. And you could try to look up binary letters and you could see what he wrote.
That's WotC?
This is WotC. WotC's our cute little, silly little round ball robot, and then this is Rosie.
But it shows you what it is. It says...
Isabella doesn't know what she's talking about. She's just doing something else. And Isabella, actually, she picked up a marker instead of a pencil to color hers in, and that could be a great way for you to also color a little faster. Sticker. I'm curious if we have any questions that came in that we can talk about before we head over to Zoom.
What kind of...
We're doing some great job with like quick little lessons today, and then lots of fun in Zoom.
Can people draw whatever they want, or do they have to do something space related?
You can draw whatever you want. Yes. So the big thing right now is that you do need like just one color. If with your friends or your siblings you wanted to try with more colors, you could do that. You could, instead of doing just 0 and 1, you could make it easier by doing like 0, 1, 2, 3, 4. And then that would give you black and white for the 0 and 1, and then maybe 2 is red, and 3 is blue, and 4 is green. And then you could have a few different colors that you could use. But we're not going to do that today in Zoom just because that adds a lot of extra depth to it. But that is how you would get color images, is instead of, we still have 0s and 1s, but it's just a much longer code for each color. Isabella has a question.
You know the first picture? They said that they only use 0s and 1s for the first picture.
First picture. This one?
Yeah.
Of Mars, yes.
Yeah, but then how did they know which color they are if they only use 2 numbers?
Yes, so Isabella has a great question. If our data came back in 0s and 1s, how did they know how to color by number? Because this color by number has things like 130 to 140 or 230 to 240. Like, what? That doesn't sound like just 0s and 1s. And she's totally right. It's not just 0s and 1s. But our 0s and 1s can make up different binary numbers. So, quick way to answer our question here. We only have 0s and 1s, but we can have more than a 0 and a 1. So if we wanted to write 0 in binary, that's just 0. If we wanted to write 1 in binary, we write that as 0, 1.
And if we wanted to write 2 in binary, we'd write 1, 1. There's 1 and the 1. But now if we want to write 3 in binary, we need a whole nother set. No, this is 1, 0, sorry. This is 1, 0. There. And then 3 in binary would be, that would be 1, 1. So you're sort of getting all this thing. And the thing is that this spot is worth 2. So 2 plus the 1 spot is 3. But then if you want to get 4, you have to have 3 spaces to be able to do it. So you'd have 1 here, and this was worth 2. This is worth 1. This spot's worth 4. So you have 1, 0, 0. And then for 5, is that the way the 5 goes upside down? I'm not sure. You have your 3 spots, and this one's worth 4, 2, 1. And so 5 is the same as 4 plus 1. So I do 4 plus 1, so it'd be 1, 0, 1. And you can imagine I can actually build this up really long to get to it. So I'd have 4, 2, 1, and 6 is 4 plus 2, so that's 1, 1, 0. And if I wanted to write a big number, I would just have more spots for my 0s and 1s. Oh my gosh, I can't write upside down. But this would be like 1, 2, 4, and each time I go and I multiply it by 2. So this would be 8, 16, 32, 64, 128, 256, which way does the 2 go? 256. So even with these numbers right here, I can go all the way up to 256. So the Mariner 4 mission might have all of their numbers that come in as a big set of 0s and 1s. 0, 1, 1, 0, 0, 1, 1, like that. And that would give us a number that we could then say, Okay, hang on, Georgia. This is 128 plus 32 plus 16 plus 2 plus 1. Okay, off the top of my head, that's 160. And that's 176, 178, 179. So this would be 179. So when we see 179 on this guy right here, it's not actually, it didn't come from Mars as 179. It came from Mars as 010110011. But we took that chunk and we put it down into 179. And so that's how we can get these larger numbers that we can then use for colors and whatnot. That's a great question, Belly. But if you're only using 2 colors, you're good to go. You don't need to worry about all of the extra numbers.
I'm going to use more than 2 colors for mine.
Isabel's going to use more than 2 colors for hers. But when we transmit today, we're only going to use 2 colors, so it'll turn into a black and white, which is totally fine. So, do we have other questions? Or shall we switch over into Zoom?
I think we're going to switch into
Georgia
Zoom.
has a beautiful unicorn she's making, multiple colors. But it's going to even, I think it'll transmit to being really pretty anyhow.
We do want to say hi to...
I would love to say hi to somebody.
Calero.
Oh, hey Calero and maybe Sky. How are you guys?
And
I'm excited you guys are back.
Jack Sloan showed up.
Hi, Jack. Yes.
And Millie and Lila were both here.
Yay, Millie and Lila. They had some great projects yesterday. I mentioned Lila's project in the beginning. It was awesome.
It was awesome.
Yeah, she really worked on overcoming something that didn't work, which is important in science. It's a really good skill.
And I think we're ready to go to Zoom. Let me get the link going.
All right. So we'll head over to Zoom. We've got Tiny Dancer and friends will have their own little Zoom video if you'd like to come watch our tadpoles go through their metamorphosis into frogs. And next week we're going to have mealworms, which will turn into beetles. I'm thinking about calling them Ringo and Friends because Ringo was my favorite Beatle musician. If you don't know the Beatles, you should listen to some Beatles. And then we also have some caterpillars coming. We don't have names for our caterpillars yet, but we have 5 caterpillars coming next week too. So they'll all get their own Zoom video for friends who are wanting to watch them go through that process of metamorphosis over the next couple months as we do science. And then, let's see, you have the Zoom link and the Zoom password in our Patreon page. Just a little call out, if you want to come join us, awesome. You can just join us on YouTube every day, but if you want to get into the Zoom and you want access to all of these materials that we have printed out, then you got to become a patron. It's as low as $1 a week, so it's not much. And that just helps support everything that we're doing. Make sure you give us a thumbs up. You share all of your stuff on social media. I love seeing the pictures. I always see the good kids. I see their pictures and projects on social media, and it's a great way, and like, later in my day to be like, oh yeah, we did do that, and that was really cool, and they made a really fun project. So I love seeing all of those pictures. And And yeah, thank you so much for joining us today. Another quick one, but this is a really fun one. And I'm hoping that some of you guys make that original Mariner 4 true data from JPL image of Mars, the first one that we ever televised on TV. I'm hoping that we get some pictures of that in action. It takes a little bit, but it's a fun one. All right, so we will head on over to Zoom. And if you're ready, you can raise your hand to transmit an image, and we'll do a little random number generator to randomly pick someone. And then if you want to receive an image, you can do that in Zoom today too. We'll have lots of practice of sending and receiving images.
Okay.
It's going to be fun.
Have a good one.
Yeah, have a good one. Thanks, Georgia. Georgia's taking us out today. I like it. She's got a great unicorn. Digging it. Ooh,
Mama,
and Isabella.
You know the polar beats? About the size of the squares here, and these are the size of the squares in my math book.
Ooh.
So I could just line them
You
up.
can make a perler. You can plan out a perler project.
No, I'm going to do that.
Is this what you, Mama? Is this what you use my paper for?
You could use your graph paper. See how it lines up? It's the same.
All right.
But I'm going to use it for the